Okay, today we're going to be looking at how to find angles using our trig functions. So this is kind of a fun day. What can we do to using the sine, cosine, and tangent? How can we possibly find our angles? And this is kind of fun because we already know how to use sine, cosine, and tangent, and we know what they stand for. But at the top of our page, let's go ahead and write in SOHCAHTOA, because we still need to use SOHCAHTOA, sine, cosine, tangent. Again, the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So for the inverse tangent, the definition is, and we're going to use the second key and then hit the tangent button. It's when we're looking for an angle and we have the opposite and we divide it by the adjacent and we hit the second tan key and hit enter. And the inverse of the sine key, which is sine to the -1 or second sine, is when we have the opposite and we have the hypotenuse, and we're going to hit second sine, enter, and we'll get the angle. And the inverse of cosine is when we have the adjacent side to the angle we're looking for and the hypotenuse. So we're going to hit the second cosine button and enter, and it will give us the angle. So if you're finding a side, you're always going to use, just like we've been practicing, sine, cosine, and tangent. But when you're finding an angle, you're going to use second sine, or sine to the -1, cosine to the -1, tangent to the -1. That's telling the calculator that, hey, I've got a couple of sides here. Can you feed me the angle? Can you give me the angle? So these are called the inverse keys, and you have to hit the second button, which is in your top left, and then the cosine, the second the sine, the second the tan. And you'll see on your window, when you hit second sine, for example, it'll say, it looks like sin to the -1. So let's do some practice here. What we're doing is we're going to approximate this angle. Angle A, we don't know what it is, but we know the opposite to the hypotenuse has this ratio, which means 36 over 100, 36 100ths. So that's how the opposite compares to the hypotenuse. So in your calculator, hit second sine, and then you can do 0.36 because it's in decimal form. And we're going to get, let's see, we're rounding to the nearest tenth of a degree. It will equal 21.1. So what we're saying is if the opposite to the hypotenuse has this ratio, the angle is 21.1. Okay, let's practice this one. This should say 5 over 8. So let's go ahead and put that in. So the tangent of an angle is 5 to 8, which means the opposite over the adjacent has the ratio of 5 to 8. So we're going to get second tan, and then 5 divided by 8, and close your parentheses, enter, and we get 32 degrees. And for C, again, now this is saying that the cosine, so the adjacent to the hypotenuse, has the ratio of 35 over 100, which can be written as a decimal, 0.35. So we go second cosine, second cos, 0.35, close the parentheses, and we get 69.5 degrees for that angle. Okay, over here, if the tangent of A is 0.42 or 42 hundredths, that means the opposite to the adjacent has the ratio of 42 over 100. So we're going to hit second tan, 0.42, close your parentheses, and we get 22.78, so I'll round that to 22 0.8 degrees to the nearest tenth. And the sine of A, let's write this in, 7 over 10. So you could write 0.7 because that's 7 over 10 in decimal form. So we'll go second sine and 7/10, close the parentheses, and we get 44.4 degrees. And this one is not in here. We'll have to put in a 4/5. Okay, so the second, and that's a cosine, so that's adjacent over hypotenuse. 4 divided by 5, close it up, and we get 36.86, 36.9 when we round to the hundredths place. Okay, there's a little practice for us. Let's get into some problems now. Okay, approximate the measure of angle A to the nearest tenth of a degree. So here's angle A. Let's label the sides we do have. Opposite, because we have to walk over here, and adjacent, and hypotenuse we don't really care about. So which function should we be using here? O and A? That's right, it's tangent. So we're going to go tangent to the -1 because we're looking for that angle A, and we're going to feed it the opposite over the adjacent, which is 14 divided by 4. 14 over 4. So let's do that in our calculator. Second tan, 14 divided by 4. And let's see, rounding, let's see, to the nearest tenth, 74.05. So we'll round that to 74.1 degree. Over here on B, from angle A, we'll put a dot right there. We've got the adjacent, this is right next to us. Oops, I'm sorry, this is the hypotenuse up here, and this is the adjacent. We're right here, opposite, we don't need, we don't care about. So which function is adjacent and hypotenuse? And that's the ca and SOHCAHTOA. So it's cosine to the -1 because we're looking for an angle, and we'll give it the adjacent over the hypotenuse. Okay, so second cosine, 7 divided by 12, close those parentheses, 54.31. So we'll round it to 54.3 degrees for angle A. Okay, here we are, angle A on C. Our opposite side is 5. Our hypotenuse across from the 90 is 11. Opposite and hypotenuse. That's the SO in SOHCAHTOA. So we're going to use the sine function and use the inverse because we're looking for the angle. Opposite over hypotenuse is 5 divided by 11. So we'll go second sine in our calculator, 5 divided by 11. And we get 27.035. So 27.0 or 27 degrees. Okay, here's angle A on problem D. Opposite is 10, adjacent is 22. Don't have the hypotenuse. O and A, that sounds like TOA, so I'm going to use the tangent function, and I'll put in the opposite over the adjacent. 10 divided by 22, close up those parentheses, and we get 24.44, so I'll round to 24.4 degrees. Okay, now that we know sine, cosine, and tangent so well, it's easy to switch over and use the inverse functions to find angles. Now let's turn to page 15. Okay, these problems at the top are very similar to what we were doing, just warm up. They're giving you the ratio. Just plug in second sine and put in the ratio they've already given you. And now these you're rounding to the nearest whole degree for those 6 problems. Now here you get to the real problems, I call them, when you have to figure out SOHCAHTOA. So at the top, write SOHCAHTOA, and you decide from this angle, the reference angle, adjacent, hypotenuse, label them. Then look here, where do I see an A and an H together? Right here, AH, so C stands for cosine. So for this one, I'm going to use cosine, and I'll use the inverse because I'm looking for an angle, and feed it the adjacent on top, the hypotenuse on the bottom. Okay, let's check this one. Second cosine, 6 divided by 8, and we get 41.40. So I'll round it to 41 degrees because we're rounding to the nearest degree. Okay, from this reference angle, I see I have the hypotenuse and I have the adjacent. From this reference angle, here's the hypotenuse and here's the adjacent. And from this reference angle, oh, I see the opposite in the hypotenuse. Excuse me, you can tell I'm pretty sick today. Continue on using your SOHCAHTOA and making your calculator do all the work for you. I want you to finish through page 16 and stop there, and we'll be grading those tomorrow. Have a good day, everybody.